friends, and welcome to edupediaworld.com, your destination to online education. Friends, today we are going to start with the continuation part of the Mendeleev's classification of elements under the topic of the periodic table. So, dear friends, we have already discussed the first part where we discussed a brief history of the scientist Mendeleev. We learned the classification of Mendeleev's periodic table and the essential features of this table. Now we shall discuss the gaps, merits and demerits of Mendeleev's periodic table. So let's start with the part 2 section, which first be the topic of the gaps in the Mendeleev periodic table. So the classification of the 10 known elements, Mendeleev was guided by two factors. First, with the increasing atomic masses. Second, the grouping of the similar elements together. Now, in order to make sure that the elements having similar properties fell in the same vertical column, or we can say group, he left some gap in his periodic table. These gaps were left for the elements which was not known at that time. He thought that these elements would be discovered later on, and even predicted the properties of these unknown elements by studying the properties of neighboring elements. The missing elements of the Mendeleev's periodic table were discovered later on, and the properties were found to be very close to those predicted by him. To understand this concept, let's take an example and understand it more effectively. For this, I shall make a section of his periodic table. First with the hydrogen, lithium, sodium, potassium. Then I shall make this second one with beryllium, (39) for the potassium, 24 for the magnesium, 40 calcium, (11) for boron, 27 aluminium, next we have carbon, silicon, titanium. So friends, you can see here there is a big gap between the calcium and titanium, or you can say in the group of boron, aluminum, and there's a space left behind for the unknown element. So the element titanium, you can see here with the atomic number 48. This is found to be the similar property to the element silicon. So on the basis of similar property, he placed the titanium under silicon, and this left a gap below aluminum. here, right? From this gap, he predicted that the existence of the element which he said would be discovered later on. He even predicted the properties of that undiscovered element by studying the properties of the neighborhood. This element was discovered 5 years later and was named gallium. That is, this gap was filled by element gallium, which was predicted by him and was discovered 5 years on with the atomic mass of 69.7, having density of 5.91 grams per cc, and the melting point is 302 kelvins with valency of 3 electrons. Its properties was found similar to boron and aluminum as predicted by Mendeleev. So it took the gap and gallium was placed under aluminium. So now let's talk about some merits of this classification. First is the grouping of elements. That is, he generalized the study of the elements, then known as the study of mere 8 groups. That is, he grouped the elements on a more fundamental basis of atomic mass as compared to the earlier attempts at the classification of elements. Second, gaps for undiscovered elements. Yes, Mendeleev periodic table left proper gaps in periodic table for the then undiscovered elements like gallium, scandium, and germanium. And when these elements were discovered later on, they were placed in those gaps without disturbing the existing elements. Even when a whole new group of elements we call inert gases or noble gases was obtained or discovered, it got a place in the periodic table in the form of a separate group. It did not disturb the original arrangement of the Mendeleev's periodic table. Third, the prediction of the properties of undiscovered elements. Yes, he predicted the properties of the unknown elements on the basis of the product properties of the elements lying adjacent to the vacant slot. As we just discussed about the gallium, there are much more germanium, scandium, though he also had incorrected atomic mass corrected. Yes, he was able to correct the values of the atomic masses of the elements like gold and platinum when he placed these elements going strictly by the similarities in their properties. That is, the error in the atomic weights of some of these elements on the basis of their positions in the periodic table. Now, if Mendeleev periodic table was a great help in the study of elements, but a few anomalies could not be explained on the basis of his periodic law. So let's discuss the defects of the Mendeleev's classification of elements. So let's have a discussion on the defects of Mendeleev's periodic table. First is anomalous pairs, that is argon with atomic mass 39.9 precedes the potassium with atomic mass of 39.1, cobalt with atomic mass 58.9 precedes to nickel of atomic mass 58.6. That is, the element did not follow Mendeleev's principle, that is, of the atomic mass increasing atomic masses. Second is the position of isotopes, that is, isotopes are the atoms of the same elements having similar chemical properties but different atomic masses. Different atomic masses of same element, right? If the elements are arranged according to the atomic masses, the isotopes should be placed in the different groups of the periodic table because they have different atomic masses. So the isotopes were not given separate places in Mendeleev's periodic table. So now we can say that according to the Mendeleev periodic table, the isotopes of an element must be given separate place in the periodic table since they have different atomic masses but they were not assigned a separate place. So we write no assignment of isotopes in Mendeleev's periodic table, right? Thirdly, we have grouping of chemically dissimilar elements, that is, elements such as copper and silver bears no resemblance with the alkali metals, having no similarity with alkali metals like lithium, sodium, etc., but they have placed together in first group. First group. This actually violates the Mendeleev periodic law. Next we can write the fourth defect is the separation of chemically similar elements. Chemically similar elements. Like elements which are chemically similar such as gold and platinum have placed in separate groups. Let's write down gold and platinum have similar properties but have placed in different groups, right? Next defect is the electronic arrangement. This means it does not explain the electronic arrangement of the element, that is the electronic configuration of the element. Sixth is the position of the hydrogen. That is, hydrogen was not given a fixed position. It was considered in a group 1A as well as in group 7A because it formed a positive ion in HCl but also have a negative ion in NaH. That is when it formed the hydrochloride or sodium hydride. This creates a positive ion and this creates a negative ion, so the position of hydrogen was not placed properly. So friends, these are some defects which came in the Mendeleev's periodic table, which gave rise to the modern periodic table by Henry Moseley, that we shall discuss in the new learning section. So we have the anomalous pairs, we have the position of the isotopes which was not clear, that is which was not given. Grouping of chemically dissimilar elements were kept together and the chemically similar elements were separated in the different groups. Also, the electronic configuration of the elements was not given and the position of hydrogen was not fixed. These are some anomalies of the Mendeleev's table which give rise to the modern periodic table. Now friends, I shall end up with this session. I hope you have understood all the underlying topics and subtopics. Now it's your time to do an activity where I have given a very small and easy question to you. You can do it in your notebooks. When Mendeleev placed element titanium below silicon in his periodic table on the basis of their similar properties, a gap was left below aluminum. Name the element which subsequently filled this gap. I hope you can do this question. If you have gone through this video properly and attentively, you can do this easily. So next discussion will be the modern periodic table. Thank you.